Talking about the outer core. Big difference between the inner core and the outer core.
The inner core's on the inside, the outer core's on the outside.
Graham? Yes, the outer core is actually completely molten.
The inner core's solid.
Yes, good job.
Okay.
Inner core is solid, outer core is liquid. It's molten. Well, what is its makeup? What's the chemicals that are molten? Chris?
Iron and nickel.
Still iron and nickel. Okay. So we saw that same representation. Still 80-20. 80% iron, at 20% nickel. Now this is actually kind of neat. Because if it wasn't for our outer core, we would not be here today. Stacey?
Wait, what did you ask?
I didn't ask you that, I just stated it.
Oh.
Yeah, so if it wasn't for the outer core, we wouldn't be here today. Because the rotation, because as that's in a molten state, it's actually rotating around the inner core, flowing around the inner core.
Yeah.
And by doing that, it actually creates magnetism. And what that does is create a magnetic field that goes around the entire Earth. And it's that magnetic field that we're going to learn about on Tuesday, or on Monday rather, that protects us from the radiation that comes from the sun. All right, it's all because of this little section right here, this tiny little 1,000-mile section of the Earth. So I guess you need to make sure you understand that the rotation of the outer core creates the magnetosphere.
Stacy said leave it on longer so she can write it down.
It's right there.
We moved too fast.
So guys, that's really, really important. You guys need to make sure you get that on your notes. That is the rotation of the outer core is what gives us the magnetosphere. The magnetosphere. And that's been kind of cut off here. We'll write that off. Magneto. And that's something we'll, like I said, we'll learn about on Monday. Or maybe we'll learn about that tomorrow. Yeah, fun stuff. Now, guys, at this point, think about this journey. We're 4,000 miles deep to the center of the Earth. This is 1,000 miles of that. The inner core is another 1,000, so how much is left over? 2,000. Well, you'll notice here in this diagram, the majority of that is made up of the mantle. Guys, the mantle is 80% of all the volume on Earth. That's insane. When we think about, you gotta think about a ball. When you're looking at all the volume in a ball, the mantle would make up 80% of that volume. It's a huge chunk. But what does the mantle look like? What does the mantle look like?
Mostly stone and the other, like.
What consistency is it? Is it solid? Is it crumbly? Is it molten? Is it pure liquid? I mean, what is it?
It's solid.
All of them?
No, I'm talking about the mantle.
And no, it's not solid.
Oh.
It is molten. Which is similar to liquid.
It starts out
But not really.
with
What? No, most of our oil is actually down in the essence. Well, no, it's actually not even that far down.
Is there chemicals in it?
So, the thickness of the mantle is another 2,000 miles thick. Guys, that means our crust doesn't even exist on this layer. you were to actually notice right here they add this crust, it is super thin. Do you guys actually know how thin the crust is?
Super.
The thickest section of the crust, which is from the top of Mount Everest to the bottom of that continental plate, is only 70 miles. Now you put that into scale, the mantle is 2,000 miles thick, and our crust is only 70 miles.
Why does it say 1800?
It kind of changes from time to time. And within the mantle is a very special place because that's where we get convection currents. And it's those convection currents that drive plate tectonics. What is convection? Can someone describe me how convection works? Anyone?
Graham.
Hi, Graham. Yeah, my husband works. Has anyone ever boiled macaroni before?
Yeah.
Yeah.
Not
Right.
macaroni.
So you got the pot out, right? Put it on the stove, put some water in there,
Yeah.
I mixed it.
and then we throw in the macaroni.
Yeah.
And then what you start to notice is the macaroni starts like floating to the top.
Yeah.
And what's it doing when it hits the top? It flows back down to the bottom, right? Okay? It's kind of like a lava lamp, which I should have plugged in this morning. Alright, now, with the lava lamp and the macaroni, it's the same thing. You have this water that gets heated at the bottom of the pot, right?
Right.
And because it's getting heated, its density decreases. Because the volume's increasing, which makes density decrease. So as I'm getting heated, my density decreases and I begin to rise up through that column. Stacey.
That thing, that bottle thing that you had, how come when the white and the blue, when it starts to, how come there was like, it was blurry right there and then it was clear at the top?
Because what you're seeing there is there's two different liquids in there. You have rubbing alcohol and you have salt water.
Oh, it's
And so what they're doing in the middle is they're separating themselves. And so the reason why it looks blurry is it's actually distorting the light waves as the light passes through it.
So wait, where does all the blurry stuff go when it puts in?
So as it separates then,
Oh,
this liquid goes here,
okay.
this liquid goes on the bottom, and now that it's consistent,
It's
you get a consistent
right.
bending of the light.
Alright.
So back with the convection currents. So we have the heat as it's rising. As it rises away from the heat source, what does it start to do? Come on guys, back with me here. Think. Morgan. It gets colder. Why do things get colder? What does it do?
Freezes.
It contracts, right? And it condenses. And as I get colder and I condense, what happens to my density?
It gets hot, bigger, more.
It gets more. Okay, so I get denser. And as I get denser, what do I start to do then? I fall back down to the heat source. Then I warm back up and back up to the top. So, what?
It's like a lava lamp.
It's exactly like a lava lamp. So what we see in the mantle is we actually see this current, so we get hot currents here and they rise to the top. But once they're away from that heat source, they begin to cool and they sink back down. And so then it's just this perpetual cycle of convection currents. And that's really what's happening in the mantle. Now, you guys ever melted cheese before in the microwave or in the stove? Right? Already made some queso dip. Okay? So you melted the cheese, but then you let it sit a little bit longer on the countertop. What starts to happen? It's hard, right? Right at the top, you start to get this thin little film. Right? The layer kind of looks like crusty layer. But it's still very flexible, right?
Right.
Okay? So that is essentially the asthenosphere. The asthenosphere is this thin layer just above the mantle. It's that very outer edge of the mantle, where the mantle is just finally starting to cool to the point where it becomes solid. But it's not solid rock, it's just solid. So it's still able to bend and flex. Okay, it's very pliable. Okay, so that's what you guys need to know about the asthenosphere. What?
So wait, you know how like when you put peas or corn, you put butter in it, but you leave it on the stove for a little bit, how the butter like all comes to the top?
Yeah.
Is that the same thing?
Yep.